Let's see types of machine learning and algorithm. There are several types of machine learning, each suited for different kinds of tasks and data structure. The main types are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. What is supervised learning? See, in supervised learning, the algorithm is trained on labeled data sets, meaning that each training example is paired with an output label. That means we have to find out after training the output. The goal is to learn a mapping from inputs to outputs. That means your input is known and output is known. So we have to find out a mapping between both. That can be used to predict levels for new unseen data. Example, classification. Assigning inputs to one of several predefined categories. Example include spam detection in emails, image recognition, and sentiment analysis. So in classification, what happens? We have several predefined categories. According to that, we will we will train the data to classify the data according to its various categories. Like we classified some spam emails and some image recognition, like different types of image will be given to this algorithm and it will check what kind of image is that one. Regression, predicting a continuous output variable. Examples include predicting house prices, stock market prices, and temperature forecasting. That means this is mainly for predicting. So in regression, what happens? This is mainly for predicting a continuous output variables. So some data, on some data it will be trained and it will predict the future value, like predict house prices, stock market prices, or temperature forecasting. Now see classification algorithms. So first is logistic regression, used for binary classification tasks, predicts the probability of a binary outcome. Binary, that means either yes or no. K nearest neighbors classifies data points based on the levels of their nearest neighbors. That is, whatever will be its nearest value, based on that it will be classified. Support vector machines finds the hyperplane that best separates different classes in the future space. Naive Bayes, based on Bayes theorem, assumes independence between features. So according to Bayes theorem of probability, it will find out the features between data. Decision tree, tree-like models of decisions, splits the data in subsets based on feature values. That means according to the values of the data, it will split them in different models. A random forest, an ensemble of decision tree, reduces overfitting by averaging multiple trees. That means it reduces the overfitting of data. Gradient boosting machines, GBM, builds an ensemble of trees in a sequential manner where each tree corrects errors of the previous one. So this is mainly for correcting the errors of previous data. Neural network model complex relationships with multiple layers of interconnected nodes. So in neural networks, we will try to find out the relationship between different layer of interconnected nodes. Now see regression algorithms. Linear regression models the relationship between input feature and the continuous output variable. So here, this is the relationship in linear regression. We find out the relationship between input features and its continuous output variable. Ridge regression, linear regression with L2 regularization to prevent overfitting. So ridge regression is forward what more complex than linear regression, and there are some overfitting of data in case of linear regression which it will prevent. Lasso regression, linear regression with L1 regularization which can result in sparse models. So there are different types of regression algorithms. Next is polynomial regression. Extends linear regression by considering polynomial relationships between features. Support vector regression applies SVM principles to regression tasks. Decision tree for regression predicts continuous value by partitioning the data spaces. That means here the data will be partitioned according to algorithm and it will predict its continuous value. Random forest for regression aggregates predictions from multiple decision trees. Gradient boosting of for regression sequentially builds trees to minimize prediction error. So this one is for minimizing prediction errors. Gradient boosting for regression. Neural networks for regression uses neural network architectures to predict continuous output. So this will use neural network of architecture to predict the outputs. Next is unsupervised learning. We have seen supervised learning, now unsupervised learning. In unsupervised learning, the algorithm is given unlabeled data. See, there is unlabeled data and must find patterns and a structure within the data. So here unlabeled data has been given to algorithm and it has to find out patterns and a structure with the data. The goal is to enter the natural structure present within a set of data points. So here we have to find out natural structure present within a set of data points. That means what the data is trying to tell us. Examples: clustering, grouping similar data points together. Examples include customer segmentation, market basket analysis, and document clustering. So in clustering, what we do, we group similar data points together. Some example: customer segmentation, market basket analysis, and document clustering. That means same types of data be groups together. Dimensionality reduction, reducing the number of variables under consideration. Examples include principal component analysis and TSNE. First, the clustering algorithm. K-means partition data into K cluster by minimizing the variance within each cluster. That means it minimizes the variance within each cluster. That means there will be not much difference. Hierarchical clustering builds a tree of clusters, can be agglomerative or divisive. DBS can density based spatial clustering of applications with noise, groups data points based on density, identifies clusters of varying shapes and sizes. That means in DBS can be different data points are groups based on its density, so it will identify its clusters of different shapes and sizes. Mean shift shifts data points towards the model of density distribution. So these are the clustering algorithms. Dimensionality reduction algorithms. First is principal component analysis. In PCA, reduces dimensionality by transforming data into a new set of orthogonal axes. So these are principal components and these orthogonal axes are principal components, and here the dimensionality of this transformed data will be reduced into a new set of orthogonal axes. Linear discriminant analysis finds the linear combination of features that best separates classes, also used in supervised learning. Next is T-distributed stochastic never embedding TSNE reduces dimensionality while preserving local structure of the data used for visualization. Autoencoders, neural networks that learn to compress and restructure data. Next is semi-supervised learning. See, semi-supervised learning is a middle group between supervised and unsupervised learning. So this is middle group between supervised and unsupervised learning. It uses a small amount of labeled data and a large amount of unlabeled data. That means a small amount of labeled data and large amount of unlabeled data for training. This is a mixture of both supervised and unsupervised, and more unsupervised. See, large amount of unlevel data and a small amount of level data, that means less supervised. This approach is useful when obtaining a fully leveled data set is expensive or time consuming. Examples: improving text classification by using a few level documents and many unlabeled ones. Enhancing image recognition systems with a small number of labeled images and a large set of unlabeled ones. Common algorithms: self-training uses a model trained on labeled data to predict labels for unlabeled data and retrains iteratively. That means model trained on labeled data to predict labels for unlabeled data. That means there are unlabeled data and it will predict in labels for. Code training trains two model on different views of data and uses them to label unlabeled data for each other. That means two models are trained on different views of data. Graph-based semi-supervised learning uses graph structures to propagate labels from label to unlabeled data. And last is reinforcement learning. Reinforcement learning involves training an agent to make a sequence of decisions by interacting with an environment. That means here training an agent. One agent is trained to make a sequence of decisions by interacting with an environment. Let's see. The agent learns to achieve a goal by maximizing cumulative rewards through trial and error. Examples: game playing AlphaGo, which learn to play Go at a superhuman level. Robotics training robots to perform tasks like walking, grasping objects, or navigating environments. Recommendation systems that learn to make personalized recommendation over time. Key concepts. So these are the key concepts for reinforcement learning. Agent, the learner or decision maker. Environment, everything the agent interacts with. Actions, the set of all possible moves the agent can make. A state, the current situation returned by the environment. Reward, the feedback from the environment after an action. Policy, the strategy that the agent employs to determine the next action based on the current state. See some common algorithms of reinforcement learning. Q learning, a value-based method that learns the quality of actions, telling an agent what actions to take under what circumstances. Deep Q networks, DQN, combines Q learning with deep neural networks to handle high-dimensional state spaces. Policy gradient methods directly optimizes the policy by updating policy parameters in direction or direction of expected reward. And actor critic methods combines policy gradient methods with value function approximation. So these are some machine learning algorithms and its different types.